Hello, and welcome to our 11th clinic in linear algebra. Today's clinic, we're going to be looking at Cramer's rule. Right, so Cramer's rule is a way to solve a square system of linear equations by using determinants instead of row reduction. Right, so it's important to note that we can only use Cramer's rule on a square system. Right, so same number of equations as we have unknowns, right? Because you can't have a determinant of a non-square matrix. Right, so first thing we want to do in this system is just rewrite the system. Right, now take note of our coefficient matrix. More room, right? So, and I'm also going to take note of our constant vector. Okay. First, we're going to want determinant of A. Right? We wind up getting as our determinant -22. Now we're going to want determinant of what we call A1. So we find the matrix A1 by taking the first column of A and replacing it with the vector B. Right, that'll be a determinant of -66. Now we want determinant of the matrix A2, right? So what we do here is we replace the second column in A with our vector B. Right, that would give us the determinant of 22. Finally, we're going to want determinant of A3, and to get A3, right, you guessed it, what we do is take the third column of A and replace it with our vector B. That'll give us the determinant of -44. Right, so what do we do with all these values? Well, this will tell us that X, right, so the first unknown, it's the determinant of A1 divided by determinant of A, okay? So this is -66 divided by -22, which is 3. Our second unknown would be the determinant of A2 divided by determinant of A. That's 22 over -22, we get -1. And then the third unknown would be the determinant of A3 over determinant of A. So -44 over -22, that gives us 2. Right, so solution to this system, 3, -1, and 2. And so again, let's take note of our coefficient matrix. And our vector. So let's calculate the determinant of A. Right? That is going to be 5. And now let's do the A1, A2, and A3. All right, so remember, what we do is we take the first column rather of A, replace it by B. Okay, so you can calculate that determinant to be 20. So determinant of A2, right? So remember, we take the second column of A and replace it with B. Right? You can calculate that determinant to be -10. And now the determinant of A3. Right, so what we do is replace third column of A with B. And you can calculate that determinant to be 15. Right, so we had what, X, Y, Z again, right? So first unknown, X, would be determinant of A1 over determinant of A. We get 20 over 5, which is 4. Y would be determinant A2 over determinant of A, -10 over 5, that gives us -2. And finally, Z, determinant of A3 over determinant of 5. That's 15 over 5, which is 3. So the solution here, right, 4, -2, and 3. I don't need that. All right, so for this system, right, so we want to do the same thing, right? So set up the coefficient matrix. Right, there is no Z, so the coefficient is 0. Right, then set up our constant vector. Now we want to calculate the determinant of A. That'll give us -132. The determinant of A1. Right, so replace column 1 of A with B. That determinant's -36. The determinant of A2. Right, replace column 2 of A with B. That determinant is negative 24. Right? And then finally, determinant of A3. Right, so we replace the third column of A with B. That determinant is 12. So X would be determinant of A1 over determinant of A. We get 3 over 11. Y is the determinant of A2 over determinant of A. So that'll give us 2 over 11, right? And then Z, determinant of A3 over determinant of A. That'll give us negative 1 over 11. So our solution here, 3/11, 2/11, negative 1/11. This system here, right? So it's going to be same idea, yeah. But instead of x, y, z, we have x1, x2, and x3. Right, so you want to set up the coefficient matrix. Right, in the second equation, we do not have an x3, so it's 0. And in the third equation, we do not have an x2, so that coefficient is 0. Right, we want our constant vector. Yeah, now we just calculate determinant of A, determinant of A1, determinant of A2, and the determinant of A3. Yeah. The determinant of that we get as negative 11. Okay, so now A1, we need to replace column 1 of A with B. Get a determinant of 30. It's a determinant, oh my, that's a hideous looking 2. Determinant of A2. Right, so we replace column 2 now of A with B. And so that's going to give us 38. So determinant now of A3, we take column 3 of A and replace it with B. And that determinant is 40. Right, so x1, determinant of A1, over determinant of A, we just get negative 30/11. x2, determinant of A2 over determinant of A, we just get negative 38/11. x3, determinant of A3 over determinant of A, we get 40/11. So the solution, negative 30/11, negative 38/11, and 40/11. now look at a 4x4 system. Well, other than there being an extra equation, extra unknown, the process itself is still the same, right? So we want to set up our coefficient matrix. -1, -4, 2, 1, 2, -1, 7, 9, -1, 1, 3, 1, 1, -2, 1, -4. And we still want our constant vector b, -32, 14, 11, -4. Right? Now we still need to calculate the determinant of A, right? And then we're going to need now determinants of A1, A2, A3, and now A4. Determinant of A. Right, so that determinant will be -423. Right, so now we're going to need determinant of A1. Okay, so same idea. Take the first column of A and replace it with B. It's a -2,115. Determinant of A2, take the second column of A and replace it with B. That gives us a determinant of -3,384. For A3, right, take the third column of A and replace it with B. And that will give us a determinant of -1,269. And finally, to find A4, we take the fourth column of A and replace it with B. That gives us a determinant of 423. X1 would be the determinant of A1 divided by determinant of A. We get 5. X2 is the determinant of A2 over determinant of A. We get 8. X3 is the determinant of A3 over determinant of A. We get 3. And finally, X4, determinant of A4 over determinant of A, and that gives us -1, right? So the solution here would be 5, 8, 3, and -1, okay? Right? And this, of course, can be extended to any square system, right? It's just a natural extension right? 5 by 5, you're going to calculate determinant of A, and then determinants of A1, A2, A3, A4, A5, right? And then the procedure follows out the same way. Also, it's important to note, right, and it should be pretty obvious, that if the determinant of A is 0, then you can't use Cramer's rule, right? Because you can't divide by 0. All right, so that's going to do it for this clinic, right? And so that will finish up the clinics for determinants. The next clinic, we will begin looking at vector spaces. Right? Specifically in the next clinic, we're just going to cover the definition of a vector space, right? It's 10 axioms. So thank you for watching today's clinic. I will see you all in the next one.